This is an RNZ podcast. Kia ora, hello and welcome to Elemental. We're on a journey through the chemical elements to mark 150 years since the periodic table was invented. I'm Alison Balance, a science producer at RNZ who knows very little about chemistry.
And I'm Allan Blackman, professor at AUT, and I've actually written a book or two on chemistry.
Oh, I'm very pleased to hear that. Now, episode 2 is where we're up to on our alphabetical journey. So, Allan, what are we doing today?
We're going to talk about the most abundant metal on Earth, and I'll give you a couple of seconds to guess what that is. It's aluminium.
Really? I didn't know it was the most abundant metal on Earth. What are its vital stats?
It has the chemical symbol Al, and it has an atomic number of 13. And that puts it near the top of the periodic table, which means it's going to be quite light.
So we've all heard of aluminium, and in fact we use it every day. If I buy a can of soda from the vending machine here at work, it's an aluminium can and it's nice and light. So it's ubiquitous, but I don't see lumps of it lying around in nature.
No, indeed you don't. And it's not like metals such as, let's say, gold or silver or copper, which do occur naturally in their metal form. Aluminium really likes oxygen. So you take aluminium metal with oxygen and they react very vigorously and very rapidly. Now, the reverse process, getting the metallic aluminium out of bauxite, is difficult. Now, it can be done chemically, and that was the way that it was first isolated way back in around about 1827. But that is not an ideal process. The easiest way to do this, to take the aluminium out of bauxite, is to use electricity.
Aha, but you have to invent the electricity first. That's probably why they started chemically, eh?
Indeed, yes. Electricity was sort of hardly known at that stage, I guess. And so in the late 19th century, an American guy and a French guy came up with the same process almost simultaneously. It sort of beggars belief because it's a very specific process. And that's why it's named after both of them. It's the Hall-Héroult process. And briefly, it involves using electricity to give electrons to the aluminium and the bauxite. In order to do this, you've got to either A, dissolve the bauxite, or B, melt the bauxite. And bauxite melts at about 2,000 degrees.
Ooh, super hot.
Yeah, exactly. A ridiculous temperature, and that's going to take so much energy to melt it at that temperature that it's not going to be economic. However, they both found that if you mix bauxite with a thing called cryolite, then that drops the melting point around about 1,000 degrees, and then lo and behold, you're in the area when you can make aluminium from this in an economic fashion.
Now, we do that in New Zealand, don't we? I'm thinking of the Tiwai Point aluminium smelter.
We do. And what happens at the Tiwai Point aluminium smelter, to give you some idea of just how much energy is used, Tiwai Point uses around about 15% of the electricity generated in New Zealand every year.
Whoa, and I thought my power bill was big. 15%, that's quite a lot. But then we use aluminium for all sorts of things. We've already mentioned it's really light.
Yes.
Why else do we use it? Because it's not its only benefit.
Lightness, obviously, and strength. When those two things go together, that's a really good thing because you can make all sorts of materials where you require them to be obviously light and strong. So things like airplanes, rockets, those sorts of things. You can alloy aluminium with various other metals and you can make all sorts of nice materials there. It's a very conductive metal, so therefore you can use it in power lines, etc. One of its very nice features is that it's very easily recycled. And so therefore you take those old soda cans, etc., throw them in the recycling. And to make aluminium from those recycled cans only takes around about 5% of the energy that would be required to turn the equivalent amount of bauxite into aluminium. So recycling aluminium is a really good thing to do.
Fantastic. Now, I do have a very important question, which is that you and I call it aluminium, but Americans call it aluminum. Why?
Because the guy that first named it, who was a guy by the name of Humphrey Davy, first named it Aluminium. Then he had a change of heart and he decided to call it aluminum. And then finally he got it right and he settled on aluminium. And the rest of the world agreed with him. It was put that way on the periodic table. And then, for some reason in 1925, the Americans decided to revert to aluminum. and they have been at odds with the rest of the world in that ever since.
So why is IUM the correct one? Is that because there's lots of other words? I'm thinking lithium, sodium, like everything ends in IUM.
Exactly, it does. Everything ends in IUM, so why that should be the outlier, I really have no idea. I'm sure people will have written articles on this, but I couldn't find them.
Anyway, so I'm quite happy with aluminium. Tell me a really interesting fact about aluminium.
Well, we've talked about how difficult it is to extract aluminium and the fact that it wasn't discovered until the early 19th century. And in around about 1860, 1870 or so, Emperor Napoleon III of France, when he had really important visitors around to dinner, he pulled out the aluminium cutlery set because at that stage it was more expensive than gold.
Wow. And now we think silver cutlery is really posh. Excellent.
So you've been listening to Elemental, a journey through the chemical elements to mark 150 years of the periodic table. Elemental is a podcast from RNZ, and you can find us at rnz.co.nz/chemistry.
You can also subscribe to us as a podcast for free in all the usual places: Apple Podcasts, Spotify, Stitcher and Radio Public. And please tell your friends about us. Spread the word.
Hear, hear. Next time on Elemental, we're looking at americium. But until then, it's bye from me, Allan Blackman from Auckland University of Technology.
And from me, Alison Balance. Catch you next time. Bye for now.